So yeah, an exponential equation, we're going to start with an exponential equation is an equation containing one or more expressions that have a variable as an exponent. To solve exponential equations, you will need to know both ways. So if you get the bases the same, or you can take the logarithm of both sides. So you will need to know this not only for not only for a quiz, but also for your essay quiz. It'll say how do you solve exponential or logarithmic equations. So the first thing that we're going to do is write them so the bases are the same. We also did this in 7.4 a little bit. It was one of the last examples that we did. I think it was the log 32 of 8. We also did this in 7.4. But the big idea here is if we have 3 to the 2x power over here, 3 also goes into 27. 3 to what power gives me 27? 3, right? So what I can do to solve these, really I can just set 2x equal to 3 and then divide by 2 to get x equals 1.5 or 3/2. So if there is a coefficient next to the x, then you would divide by that number. But
if it was like a 3x, you divide by 3.
Correct. And like here, do you see how it's like a 8 minus x? You're going to have to do some more solving. So whatever your exponents are, you have to do a little bit more work. I think this next one's a little tricky because if this is base 9, we don't know 9 to what power gives me 27, right? So we're going to have to change both bases here. 9 is 3 squared, right? And we just said 27 is 3 cubed. So if I were to simplify these things, let me zoom in so you can see this example better, right? So once again, I made my bases the same. They're both base 3 now, right? But if you remember our properties of exponents, when we have a power to another power, we have to multiply our exponents. So we have to distribute that 2 to our exponent. And here we have to distribute our 3 on this side. Once I have that expression, I can set my exponents equal to each other. And then I can solve. Do you guys have questions on that? The changing of the bases, making the base the same, and then distributing your exponent? Yeah, it's really funky. Personally, I would add the 2x to the other side. So I get 16 equals 5x minus 9. Add the 9 to get 5x equals 25. So x equals 5. Sorry, my face is in the way. Okay. You have questions on that? So once again, we just did method 1. I'm going to zoom out a little bit. You more than likely will need to know both methods. This second method is helpful when you can't change your base. So if you can change your base, do it. It's easier this way. Because if you can't change your base, that'll involve a calculator. Does that make sense? So like here, I can't make 4 and 5 the same thing. So I'm going to have to use a different method. Does that make sense?
Oh, so you get change the base to 9 and 27.
Yeah, so 3 goes into both of those, right?
Yeah.
But like here, 2 won't go into 4 and 5.
Yeah.
So I can't do change of base, so I'm going to have to do the logarithmic way. So it says the other way is to take the log of both sides. So the way I write that is I'm going to literally put a log on both sides of these. And when I do that, if you remember from 7.4, when I have a log and then there's an exponential expression within that log, what I do with the exponent is I have to bring it out front. So I'm going to have that x minus 1 out front, and then a log of 4, and that's equal to the log of 5. And what you can do is actually convert log of 4 and log of 5 into decimals by either plugging it into a calculator, so I'll show you mine, or you can just Google it. So for those of you who are at home, just type in log 4 and it will give you an answer, right? And those of you who are here, I can show you where it is on your calculator. But typically, you'll just see the word log. So you'll hit the log button. Oops, sorry, I'm going to clear this all out. You'll hit the log button. And then you'll just type in this case, log of 4 is 0.6. Oops. That's all I'm going to type in. So I'll get 0.6 times x minus 1 equals whatever log of 5 is. Anybody? I think it's let's just round it to 0.7, right? And then to solve this, I could either distribute the 0.6, but personally I would divide by 0.6. And that will give me x minus 1 is equal to 0.7 divided by 0.6, which is 1.16 repeated. Right? And then I'm going to add 1 to both sides to get, oopsies, x equals 2.16 repeated. And remember, you really only should be using this calculator when you can't change your base. And I'm going to be looking for you to change base first, unless you can't. So once again, here, can't change your base. 15 and 2 don't have any common factors, right? So I'm going to have to take the log of both sides. Here, I'm going to rewrite this actually. I have 2 to the 3x equals 15, right? I would have to take the log of both sides. And then when I do that, I have to bring that exponent out front to get 3x times the log of 2 equals the log of 15, right? I need to get my handy dandy calculator out. What's the log of 2? That's 0.3. 3x times 0.3 equals whatever the log of 15 is. So 1.2, let's just round it again. Three times 0.3 is 0.9. And then I would divide by 0.9 to get my answer, right? X is 1.3 repeated. So once again, I think the tricky part is knowing when you take the log of both sides that you have to bring that exponent out front, and then the new part is just plugging things into your calculator, right? Otherwise, kind of the same thing. A logarithmic equation is an equation with logs and variables in it. You can solve these by using logarithmic properties. So if you get log b of x is equal to log b of y, then x is equal to y. So meaning if you have log to the same base, then these big numbers should be equal to each other. So that's one property that you need to know. The other one that will show up on an essay quiz and will have to be done on a real quiz is called exponentiating. And this is saying to undo a log, we need to raise both sides of the equation. Based on the base. So if you look, this first example, log 6 of 2x minus 1 equals negative 1. We're going to use this number here. We're going to raise 6. We're going to exponentiate using base 6 on both sides. The reason we do that is because 6 raised to the log base 6 power cancels, right? We learned that in 7.4. And here we're going to do 6, like base 6, and raise it to these powers. The reason is, remember when you have an exponential 6 and a log 6, they cancel? That's why we're going to do that. But when we do that, we're left with this expression here. And then on this side, 6 to the negative first power, remember that's 1/6. That tells you to flip it, right? And then all you'd have to do is solve for x now, so we're going to add 1. So 2x equals 7 over 6, and then divide by 2. That would mean you have to do keep, change, flip, so 7 over 6 times 1 over 2, which would give me 7/12. Funky answer. But once again, the big step here is that exponentiating. This second example is a little different because right now I have two logarithmic expressions and I have to bring them together. So if you remember when we're subtracting logarithmic expressions, what do we have to do to these? We're dividing. Beautiful. So I should have log base 4 of 100 divided by x plus 1 equals 1. So once I've combined my logs, I'm going to do the exact same thing. What number should I exponentiate with? I should be using a 4. So I'm going to do 4 to the log base 4 of 100 over x minus 1, and then 4 to the first power, right? When I do that, my log base 4 and the exponentiating of 4 cancel, and I'm left with 100 over x plus 1 equals 4 to the first power is 4. My advice to you is get the x out of the denominator, and in order to do that, I'm going to multiply by x plus 1 on both sides. So I get 100 equals 4x plus 4. And then I can solve for x. Right? You guys have questions on that? I know it's a lot of work. Okay. If I run into something like this, do you remember when I had log base 5 of x to the 4th? If you have an exponential within a logarithm, we have to take care of that, right? So I'm going to have 4 times log base 5 of x equals 8. Couldn't I just divide this 4 out? And then now I can exponentiate, right? Now I only have one logarithmic expression. There's no exponentials within the logarithms. So I can exponentiate using 5. So I'm going to get x equals 5 to the second power, which is 25. Right? Weird stuff. But hopefully, I know there's going to be a lot of examples today. But hopefully that makes sense. We're going to continue to do things like combining our logs. The issue I see with this next one is in order to add our logs, we can't do that if there's a 3 out front. So I need to put that 3 back in. And when I do that, that would give me x cubed, right? Then when I add logs, I can multiply.